Hey guys, welcome to question FM88 of the Further Maths Sharpened Study Guide. I've quickly drawn out a bit of a layout of the information you've been given for this question. This is just a rough layout. These data points aren't exactly as they appear on your sheet. So make sure that you have your download or your booklet handy. That way you can see the actual I've obviously abbreviated some of these bits of writing, couldn't fit them in there, but you'll be able to see them on your pages. So jumping straight in, this question is introduced as a rating for spaghetti bolognese out of 100 and how much of a legend the student is displayed in the scatter plot below for 19 students. So here we've got like how much of a legend the student is as a percentage. Just put a little percentage sign there. And we've got their rating of spaghetti bolognese out of 100. So as we can see here, the students who are less of a legend rated spaghetti bolognese lower, which just stands to reason. Obviously that's just a joke. It's something we've made up just to have a little bit of fun with it, but the maths remains the same. So question A says, determine the standardized value of the legend score. So they want a Z score for a student with a legend score of 56%. Write your answer correct to one decimal place. So in part A, we know we're going to be using, because they've asked for a Z score, we're going to be using our Z score formula, which is Z equals X minus mean of X over standard deviation of X. Now, the trick here is that this is the sort of the general form given to you using this formula. However, they want the Z score of the legend score, which is actually our Y value over here. So although we use this as our general formula, what they're actually asking for in terms, this is where a lot of students I imagine will get tripped up a bit, is that what we're actually going to be looking for in terms of the legend score is an actual value for Y minus our mean of Y over our standard deviation of Y. So what we actually end up with, in real terms, I think, what was the percentage? 56. So we end up with 56 minus 46.7. If we take straight from here, our mean of Y, and then our standard deviation of Y over our standard deviation of Y, which is 21.4. So calculating that out using your calculator or using your head, you're going to end up with an answer of 0.4. So the standard score for a student with a legend score of 56% in terms of their legend score is 0.4. Cool. On to part B. So part B says, use the information in the table to show that the equation of the least squares regression line for a student's legend score Y in terms of their spaghetti bolognese rating X is given by Y equals negative 24.88 plus 1.56x. So they want us to use this information here to show the equation, and I'll write what they give the equation to be. So they say that it's Y equals, so this is our regression, the equation of our regression line, Y equals minus 24.88 plus 1.56x. So that's what they've told us it is, and they want us to prove that this is in fact the case. So first of all, we're going to have to calculate our value, our value for B. So we're using the general formula. We're going to be calculating Y equals A plus BX. So we need to find values for B and A. So using formulas that you guys will have learnt in the past, B is equal to R times the standard deviation of Y over the standard deviation of X. So that is equal to, according to our stats over here, 0.796 times standard deviation of Y, 21.4, all over 10.9, like so, which ends up equaling out to 1.5628. And as we can see here, our value for B at 1.5628 well, that stands here. Well, it would round to 1.56. So that works there. However, we're going to keep this value of b just in mind. So I might actually 1.5628. 5628, just put it over here. B equals 1.5628. And the reason that we calculate b first is because we actually need our value for b in order to calculate our value for a. So you guys will have seen this formula as well. A is equal to mean of y minus b times mean of x. So what that ends up becoming is 46.7. So once again, using my values from the table, 46.7 minus 1.5628 times, and the mean of x, 45.8. So once again, whacking that into a calculator or doing it in your head if you really, if you are really clever. I mean, these are funky numbers to try and do it, so I'd recommend putting this into a calculator. You're going to end up with 24, sorry, that's a 4. 24.8762, which once again, just looking quickly up here, this is going to round to 24.88 to 2 decimal places. I've missed my negative sign. If you put this in a calculator, it will actually give you negative 24.8762. So here I have a is equal to negative 24.8762. Now you can just substitute these values in a and b into your general form over here to 2 decimal places, and you can show that, well, you can show how they figured out that y is equal to negative 24.88 plus 1.56x. Next, part C. I might actually just leave that there. Part C says, a student who gave spaghetti a rating of 66 has a legend score of 78%. Determine the residual value when the least squares regression line given in part B is used to predict this student's legend score. Write your answer correct to 1 decimal place. So there's a couple of elements to this question. Number one, we have to find what the residual value is, because we will end up, what it wants us to end up doing is determine the residual value when the least squares regression line given in part B is used to predict this student's legend score. So we're actually going to be using residual. So a residual score is equal to actual, so an actual value, minus predicted. So we're trying to find this residual. What we have at the moment, we do have their actual score, so their actual score, and what are we finding the actual for? Has a legend score of 78%. Awesome. So they have an actual score of 78. Now we need to find out what their predicted score would have been, given that they gave spaghetti bolognese a rating of 66. So we put in our 66 into our regression equation up here. So just underneath here, y, because this is our legend score, is equal to minus 24.88 plus 1.56 times, and then we've got 66. And that's going to end up giving us a y value of 80.7. So to substitute that back into our equation up here, because now we have, this is now the predicted legend score based on the fact that they gave spaghetti bolognese a rating of 66 out of 100. So (78 minus 80.7) is equal to minus 2.7. And that minus is important because when we're talking about residuals, we want to know whether we're above or below the expected value. So sorry, that was oh no, that's the whole thing. We're all good. So guys, if you have any questions about that question, please drop them in the comments below or send us a direct message on Facebook to our Facebook page, Triumph Tutoring, and someone will be sure to help you out.